Hello everyone, in this video we will tackle the introduction to partial differentiation and the concepts, rules and application of this topic. We will proceed now to the learning objectives of this topic. Our first objective is to know the definition of partial differentiation. Secondly, to know what is the notation for partial derivatives. And lastly, to know how to apply partial derivatives in an equation. The next one is the definition of partial differentiation. Again, what is partial differentiation? Partial differentiation is a process used to find the derivative of a function with multiple variables with respect to one variable while keeping the others constant. Let's proceed now to the basic example. If function x and y is equals to x squared plus y squared, then first, this is our symbol. It's like number 6 that's rotated oppositely. So this is the partial derivative of our function f with respect to x. We will get its partial derivatives with respect to x, treating y as a constant. And for y, this is our partial derivative of our function f with respect to y, treating x as a constant. And in the next one, we will know on how to compute partial derivatives. First, identify the variables in function, whether it is x or y. Second, choose the variables to differentiate with respect to. Third, treat others variables as a constant. Lastly, differentiate with respect to the chosen variables. Go ahead to the next slide. Notation for partial derivatives. The notation for partial derivatives is similar to regular derivative, with a curly symbol to indicate that only one variable is for a function of x and y. Common notations: f of x, or for the partial derivative with respect to x; f of y, or for the partial derivative with respect to y. Let's proceed for higher order derivatives. We might see second partial derivative with respect to x, and second mixed partial derivative first with respect to y, then x. Move on the next on how to compute partial derivatives. But first, remember not to forget the steps to get the partial derivatives. First step is to identify the variables in the function. We have our problem here. F of x and y is equals to 3x squared y plus 4y cubed. Find the partial of f with respect to x and partial of f with respect to y. The variables of the given is x and y. The second step is choose the variable to differentiate with respect to. The first is with respect to x. Therefore, our constant is y. F of x and y is equals to 3x squared y plus 4y cubed. Find the partial of f with respect to x and partial of f with respect to y. To get the partial of f with respect to x, first we need to derive the x squared. The derivative of x squared is 2x, and our constant y stay the same. So we need to times 3 times 2 is equals to 6. Therefore, our answer with respect to x is 6xy. And for the partial derivative with respect to y, is 3x squared plus 12y squared. Let's proceed to the solution. The partial derivative of f with respect to x is equals to 6xy, while the partial derivative of f with respect to y is equals to 3x squared plus 12y squared. Example of partial derivatives second variable. What's the derivative of x squared? The derivative of x squared is 2x. Now what about the derivative of x cubed? We know it's 3x squared. Now why we're going to treat it as a constant? So we're just going to rewrite the derivative of x to the fourth is 4x cubed, and then we won't change the y to the third. So that how you can find the first derivative? The first partial derivative with respect to x. Treat x as a variable and any other variable treated as a constant. So this is equal to 14x minus 3x squared y to the fourth plus 20x cubed y to the third. So that's the answer. That's the first partial derivative with respect to x. Now what about the partial derivative? What is the answer in that case? So 7x squared is treated as a constant. The derivative of a constant is 0. The derivative of y to the fourth is 4y cubed, and the derivative of y to the third is 3y squared. Treat x as if it's a constant, so this is going to be negative 4x cubed. Y cubed plus 15x to the fourth y squared. So that's the partial derivative with respect trigonometric functions. Now let's try a trig function. Let's say z is equal to sine x cubed to the fifth. Find dz, dx, and dz dy. So if you find the derivative of a sine function, the derivative of sine u is cosine u times u prime. So if you want to differentiate sine x squared, it's going to be cosine x squared times the derivative of the inside part. The derivative of x squared is 2x. So let's say if you have sine x to the fifth, it's going to be cosine x to the fifth times the derivative of the x to the fifth. Let's work on a problem that we have. So let's find dz dx. The derivative of sine is cosine. Whatever is inside, going to keep, we're not going to change. This is going to be x cubed y to the fifth. And now we need to differentiate x cubed y to the fifth with respect to x. We're going to treat x as the variable, y as the constant. The derivative of x cubed is 3x squared, and then we're going to multiply by the constant. So that's the answer, which we can write it as 3x squared y to the fifth, and then cosine x cubed y to the fifth. That's the answer. Logarithmic. To find the partial derivative with respect to x and the partial derivative with respect to y of this multivariable function. Here f of x, y. Solution: when we take the partial derivative of f with respect to x, we want to treat the y as a constant. So here we have the natural log of x fourth plus y to the fourth. So this derivative is 1 over x to the fourth plus y to the fourth times the derivative of the inside. Well, the derivative of x fourth is 4x cubed, and the derivative of y fourth with respect to x is 0 because we're treating y fourth as a constant. So this ends up being 4x cubed over x to the fourth plus y to the fourth. So that is the partial derivative of f with respect to x. Now we'll do the same thing and find derivative of f with respect to y. Again, it's 1 over x to the fourth plus y to the fourth. Except this time, we're treating x as a constant. So the derivative of x to the fourth is 0. And the derivative of y to the fourth, that will be 4y cubed. So we end up with 4y cubed over x to the fourth plus y to the fourth. So that's the partial derivative of f with respect to y. Partial derivatives, three derivatives. Notice for these two examples we have function of three variables. To determine the partial of f with respect to x, we consider y and z constants and differentiate with respect to x. To determine the partial of x with respect to y, we have functions of three variables. To determine the partial of f with respect to x, we consider y and z constants and differentiate with respect to x. To determine the partial of f with respect to y, we consider x and z constants and differentiate with respect to y. And to find the partial of f with respect to z, we consider x and y constants and different with respect to z. For the first example, we are given f of x, y, z equals 5xyz. To find the partial of f with respect to x, we treat y and z as constants and differentiate with respect to x. The derivative of 5xyz with respect to x is 5 times the derivative of x with respect of x, which is 1. And then we still have times yz because we are treating y and z as constants. The partial of f with respect to x is 5yz. To find the partial of f with respect to y, we now treat x and z as constants. Differentiate with respect to y. The derivative of 5xyz with respect to y is 5x times the derivative of y with respect to y, 1. And then we still have times a z because we are treating x and z as constants, is 5xz. To find the partial of f with respect to z, we now treat x and y as constants and differentiate with respect to z. And therefore, the partial of f with respect to z is equal to 5xy times the derivative of z with respect of z, which is 1, giving us a partial of f with respect to z as constant. And the answer is 5xy. Exponent point notation. And for our second example, f of x is y and z to 3 times x to the power of 3.3 times y to the power of 6.2 plus z to the 7. To find the partial of f with respect to x, we treat y and z as constants and differentiate with respect to x. The derivative of 3x to the power of 3.3 y to the power of 6.2 with respect to x is 3 times the exponent of 3.3 times x to the power of 3.3 minus 1, which is 2.3, because we're treating y as a constant, and we still have times a y to the power of 6.2, and we have plus the derivative of z to the 7th with respect to x, because we're treating z as a constant. The derivative with respect to x is 0. Simplifying 3 times 3.3 is 9.9, giving us 9.9x to the power of 2.3, y to the power of 6.2. To find the partial of f with respect to y, we now treat x and z as constants, and differentiate with respect to y. The derivative of 3x to the power of 3. Y to the power of 6.2 with respect to y is 3x to the power of 3.3 times the exponent of 6.2, y to the power of 6.2 minus 1, which is 5.2, plus the derivative of z to the 7th with respect to y, which is 0 because we're treating z as a constant. Simplifying 3 times a 6.2 is 18.6, giving us 18.6x to the power of 3.3, y to the power of 5.2. And then to find the partial of f with respect to z, we treat x and y as a constant and differentiate with respect to z. Because we're treating x and y as constant, the derivative of 3x to the power of 3.3 y to the power of 6.2 with respect to z is 0. And then we have plus the derivative of z to the 7th with respect to z, which is 7z to the 6th. So that's the answer of our two examples. Partial derivatives multivariable function. Derivatives of multivariable functions. Let's start with these functions. F of x and y is equals to x cubed plus x squared y cubed minus 2y squared. Let's start with the first partial derivative of this function f sub x, which means that we want to find the derivative of this function with respect to x and f sub y. Derivative of this function with respect to x is 3x squared, plus derivative of the same with respect to x is 2xy to the third. Note that when we take derivative with respect to x, y to the third is a constant is coefficient for x to the second. Derivative of x squared is 2x. By the coefficient which is y to the third. And derivative of negative 2y squared with respect to x is 0, because we take derivative with respect to x, and when we take derivative with respect to x, everything other than x is a constant, and derivative of any constant is 0. So this is the partial derivative of this function with respect to x. F sub y, derivative of this function with respect to y. Let's find f sub y derivative of this function with respect to y. Derivative of x to the 3 with respect to y is 0, because x to the 3 is a constant. Take derivative with respect to y, what is the derivative of x to the 2y to the third? When we take derivative with respect to y, because we take the derivative with respect to y, x squared is the constant for y to the third. And then we have to take derivative of y to the third, which is 3y squared. So derivative of x2y to the third with respect to y is 3x2y2. Finally, derivative of negative 2y2 is negative 4y. These are the first partial derivatives of this function. Now, we can find the second partial derivatives of this function. But what are the second partial derivatives? If we take derivative of f sub x, derivative of the function with respect to x, again with respect to x or with respect to y, those are the second derivatives of the function f. So, from this expression we can take derivative again with respect to x. This is one of the second partial derivatives of this function. So f sub x means that we want to take derivative of this original function twice with respect to x. This is the first partial derivative. If we take derivative of this again with respect to x, we can find f sub x of x. But what is f sub xx? We have to take derivative of this again with respect to x. Derivative of 3x squared is 6x, and derivative of 2xy to the third with respect to x is 2y to the third. Note that we take derivative with respect to x, so 2 and y to the 3 are constants. And just we take derivative of x, which is 1, and 1 times 2y to the 3 is 2y to the third. Sub xx, which means that second derivative of f with respect to x is 6x plus 2y to the third. But we can take the derivative of this expression with respect to y, and we show that with f sub xy. So this notation means that take derivative of x and respect to x, which we need here, and then take derivative of that with respect to y. So here we are taking derivative with respect to y to the variable y. Derivative of 3x squared with respect to y is 0, and derivative of 2xy to the third with respect to y. Don't forget in here, in this step, we are taking derivative with respect to y. Derivative of 2xy to the third with respect to y is 6xy squared. 2x is a constant, is coefficient for y to the 3. We bring that power 3 to the front. We multiply 3 by 2, we get 6xy to the end, so 6xy to the 2, 6xy to the 2 is f sub xy. Now let's find the other second partial derivatives. We can find the derivative of x sub y again with respect to y. Take derivative of this with respect to x, then we can find f sub y x. But if we take the derivative of this with respect to y again, we can find f sub y. Let us solve this. So we want to find the derivative of this function with respect to x. The derivative of 3x squared y squared with respect to x, 6xy squared. When we take the derivative of this expression with respect to x and y2 are constant, so don't worry about that. Take the derivative of this 3x squared and multiply by the constant. The derivative of negative 4y, when you take the derivative with respect to x, is 0 because we don't have x. So f sub yx is 6xy to the power of 2. So what's the difference between this and this? Here, we take the derivative with respect to x, then with respect to y. But here, we take the derivative of the function f first with respect to y, then from that, we take the derivative with respect to x. Now let's find f sub y, which means that take the derivatives of f twice with respect to y. The first derivative of this function with respect to y is this expression. Now, we have to find the derivative of this expression again with respect to y. The derivative of 3x squared y squared with respect to y is 6x squared y. The derivative of y to the 2 is 2y minus the derivative of 4y is 4. So this is our final answer for the first and second partial derivatives. Thank you for listening. Have a nice day.